Good day, everyone. So today we'll be talking about set. So as you can see, let's quickly take the introductory part. Set is a collection of distinct objects called elements. As simple as that, that's a simple definition of a set. It's just a collection, that is a group of a distinct object. The objects are all called elements. That's why I put it in a box, element. So always remember that the object in a set, every object that we have in a set are called elements. They are called elements. So they can be anything. Those objects can be anything. It can be numbers, probably either 1, 2, 3, or they can be letters, probably A, B, C, or they can also be symbols. We can use symbols, probably dollar or naira sign. So they could be anything. The elements of a set are unordered. We don't care how they are arranged. So the elements, that is those objects in a set, they are unordered. That is in ascending order or descending order. You don't care how it is. Just make sure that it is set and elements are inside it. As simple as that. Let me give an example for that. This is an example of set. So set A is having 1, 2, 3. That is having 3 elements. Don't forget I told you object inside a set is called element. So we're having 3 elements here, which are 1, 2, and 3. So that means A is having 3 elements. A is containing element of 1, 2, and 3. And don't forget I told you, we don't mind the way they are arranged. It can also be like this. And A is having 3, 2, 1. So this is another set. You can say A is having 3, 2, and 1. You can see it's still 3 elements. We don't mind that they are arranged. Whether it is 3, 2, 1 or 1, 2, 3. Don't forget they are arranged in ascending and descending order. So let's go to the types of set. So we have different kinds of sets actually, but I will explain each and every one for you so you can understand it very well. So that by the time we are getting into it properly, you'll be able to identify them one by one. So what are the types of sets that we have? We have number one, finite set. We have finite set. What are these finite sets? Finite sets are sets with a limited number of elements. That is to say, the elements in the finite set are limited. That is, you can count them. They are countable. Let me give you an example. Let's say A, 1, 2, 3, 5, 7. So this is a finite set now. How is it a finite set? We can count the number of elements in this set. Don't forget, elements are those numbers inside this particular set. So we can count the number of elements in this set, which are 1, 2, 3, 4, 5. That is 5 elements. So we call it finite set because we can count the number of elements in this particular set. So let's go to the second one. Is infinite set. So number 2 is infinite set. Infinite set. From the word infinity. So we can define infinite set. These are the sets that have unlimited number. Simple as that. They are sets that have unlimited number. So let's take an example. Let's say A is having 1, 2, 3, 4, 5, and then so we can say this is an infinite set. Why? It has no end. Till it keeps going, keeps going, keeps going, keeps going. That's why I call it infinite set. It has no end, so it keeps going. Let's move to another set. So number 3, we're having singleton set. So singleton set, from the word single, just one. So singleton set, these are sets that contains exactly one element, just one element. That's why I call it single. Let's look at example. Let's say A equals to. So these are our sets. These are singleton sets. They are sets with just exactly one element. You can see just one element that is inside it, just 5. That's one element. Let's go to another set. Empty set. Empty sets. What are empty sets? Empty sets are sets that contains no element. They contains no element at all. That's why I call them empty. You know, when they say something is empty, it means nothing is there. So that's how we say empty set. It contains no element. No element. As simple as that. So let's give an example, which is A equals to, you can see this is a set with nothing inside. So we can denote empty set to be like this, or empty set can also be written as this. Equivalent set. What are equivalent sets? Equivalent sets are sets that have the same number of elements but not necessarily same element. Please let me take it again. Equivalent sets are sets that have same number of elements but not necessarily same element. Let me try and give you an example so you can understand what I mean by equivalent sets. So they are sets that have the same number of elements. So that means you must know, first thing you must know that there will be two sets. So those two sets must have the same number of elements, but not necessarily same element. Let me give an example. Let's say A is equals to 1, 2, 3, and B equals to 4, 5, 6. So you can say these two sets are equivalent. Why? They have the same number of elements, that is three elements. A has three elements, 1, 2, 3. B has three elements, 4, 5, 6. So they're having same number of elements, but not same element. Only by but not same element means that A is having 1, 2, 3, B is having 4, 5, 6. So that's not the same. The elements in both of them are not the same, but they are equal. That's why I call it equivalent set. So they might not be the same thing, but they must be equal. They have different elements inside them, but they are same number of elements. Number of elements here is equals to 3. Number of elements here equals to 3. So they have the same number of elements, but different. This one is 1, 2, 3. B is 4, 5, 6. Different set. Let's go to another set. Equal set. Please, you have to be very careful between this equal set and then equivalent set. It looks somehow convincing, but let me try and explain it to you so you can understand very well. Equal sets are sets that have the same element regardless of their order. So they are sets that have the same element regardless of their order. Don't forget equivalent sets, they have the same number of elements but not necessarily same elements. But in equal sets, they must have same elements. That's why I call it equal. They must be equal. One must not be more than the other. So they must be equal. Let's give an example so you can understand. Let's say A equals to 1, 2, 3. Then B equals to 3, 2, 1. So these are equal sets. Why are they equal sets? They're having same element. That is, A is having 1, 2, 3 element. That is 3 elements. And this one B is having 3 elements, which is 3, 2, 1. So though they are not arranged, one is in ascending order, one is in descending order. So that's equal set. They are equal. A and B are equal. So we can actually say A is equals to B, which is equals to 3 elements. Also what we call universal sets. So what are universal sets? These are sets containing all possible elements. They are sets containing all possible elements. So let me give an example of a universal set. Let's say A equals to 1, 2, 3, and 4, and B equals to 4, 5, 6. So then our U, which is universal set, must be 1, 2, 3, 4, 5, 6. This is containing all the elements in A and B. So you can see it's containing all elements in A and B. That's why I call it universal set. It must contain all possible elements that we have. Let's go to another set. Number 8 is subset. So this is also type of set. So a set is said to be a subset if element in A is also in B. Simple as that. If the element in A is also in B, then we say it's a subset. What am I trying to say? Let me give you an example. Let's say A is equals to 1, 2, 4, 5, 6. So I intentionally not put 3 so that I will not think it must be arranged ascending order. So I arrange it anyhow. So then B, we are having 2, 3, 4, 5, 6. So we can say A is a subset of B. Why? Because all elements in A are inside B. So definitely we can say A is a subset of B, or B is a subset of A, because element in B is also in A and element in A is also in B. So we can say A is a subset of B because element in A is also present in B. What are the elements in A that's present in B? We have 2, 4, 5, and 6. Those are the elements. So those are the subsets of A. The element present in A that's also in B. So let's go to another set. Power set. What are power sets? Power sets are the set of all subsets of a given set. What am I saying? Let me go to an example so you can understand better. The set of all subsets of a given set. Given A to be equals to 1, 2. So then power set of A will be equals to, so power set of A will be equals to the set of all the subsets of this given set. So what are the set of all the subsets of this given set? That will be empty sets, comma. We also have 1, so we have 2, and then we're having 1, comma 2. So these are the power of a set. They are just the set of all subset of a given set. Don't forget our subsets. So the set of all the subsets of a given set are all called the power sets. Proper subset. What do you mean by proper subset? Proper subset is a subset that is not equal to the original set. As simple as that. That is to say, a proper set contains fewer elements than the original set. That is, the original set is always more than the proper subset. The original set is always more than the proper subset. The elements in proper subset are always fewer than the elements in the original set. Let me give an example. Let's take this our original set. 1, 2, 3, 4. So our proper subset will be 1, 2. So you can see this proper subset is fewer than the original subset. The original subset is having 4 elements, while the proper subset is having just 2 elements. So that's why I call it proper subset. It is lesser than the original element. So now let's go to set notation. This symbol means number of elements in set A. So that's how you write number of elements in set A. And then the second one will be A complement, or so you can either write it in two ways. A complement, you can either write it as this, or the second one, A complement. The both means A complement. That is element that are in the universal set but not in A. That's A complement. As simple as that. Those elements are in universal set but not in A. We call it A complement. And the first one is the number of elements in A. That is the number of elements that we have in A. So let's go to the next one. A union B. A union B. That is to say the combination of both A and B together. So you're going to join them together to make it A union B. That is to say they will marry each other. So let me label it 1, 2, and 3. Okay, so number 4 now. Let's move to number 4. B. So number 4 will be A intersection B. A intersection B. That is to say what is common between A and B. So what are those things that are common between A and B? We call it A intersection B. When things are common between them, we call it A intersection B. Let's go to number 5. So number 5 is going to be member of. So when you talk about member of, that's number 5. And number 6 is going to be not member of, or you can say does not belongs to or belongs to. Then number 7 is going to be subset. Number 7 is going to be subset. So when you want to write subset as in a set notation, don't forget our subset. We talk about subset the right time. Okay, so when you want to write about subset in a set notation, this is how it will go, and that's our number 7. So to write a subset, you are going to just to write it like C, and then you put one dash under it. Let me write it so you can see exactly like this. So C, that's subset. You can say A is a subset of B. That's how you're going to write it. Then let's do number 5 and 6. A is a member of B. That is, A belongs to B. Same thing. Then number 6, A is not a member of B. That is, A does not belong to B. Let's move to number 8. This one is what we call not a subset. So you can say A is not a subset of B. That is to say, A does not belong to B. A is not a subset of B. Number 9 will be A is a proper subset of B. Talk about proper subset to the other time. So A is a proper subset of B. That's how I'm going to write it. A is a proper subset of B. Exactly like that. So number 10, A is not a proper subset of B. What are set operations? Set operations are performed on two or more sets to obtain a combination of elements as per the operation performed on them. Yes, it's just operation, just like performing something. It is performed on two or more sets to obtain a combination of elements as per the operation performed on them. So we have three major types here. The first one is union set. The second one is intersection. I'm sure you have heard about them before. Intersection of sets. And the third one is difference of sets. So let's take them one by one and let's trash them out. What about this union set? I think I explained it from the last topic that we did, set notation. So if two sets A and B are given, then the union of A and B is equal to the set that contains all elements present in both set A and set B. Interpret union to be A union B equals to X such that X is a member of, I don't think I talk about such that, so that column is what goes such that in set operation, such that, or you can also use something like this, such that, like a slash like this. It also means such that. So X such that X is a member of A, or X is a member of B. Let me just explain this. So X is element in this set A and B. So X is such that X is a member of A. Don't forget the sign means member. X is a member of A, or X is a member of B. So that's how you're going to write for union set. X a member of A. So X the element must be a member of A, does also must be a member of B for it to be a union set. Intersection of sets. We talked about that one too. The intersection of sets A and B is the set containing all the elements that belongs to both A and B. And it is represented as A intersection B. Talked about that one the other time. So let's write it like that too. So we can say X. Don't forget X is an element in both A and B. X is such that, though this thing also means such that, X is such that X is a member of A and X is a member of B. We see that. So X is such that X is a member of A and X is a member of B. Don't worry, we are still going to treat some like questions on all these things after we are done with the explanation. So let's move on. So lest I forget, don't forget X so that X is a member of A, or this one is or and this one is and. So note it. It looks the same, but there is difference. So the difference is always like this. That's how you write it. Difference of sets. When you're talking about difference of sets, you're going to write it exactly like that. So it will be like a minus. And the word difference. Difference in mathematics means minus. Same thing. So difference of a set is minus. That's the symbol to represent them. So element in set A but not in set B. We say it's different of a set. Like this now. If you write something like this, it means element in set A but not in set B. So that's what the difference means. Don't forget it's different from B minus A. They are different thing entirely. This one will be element in set B but not in set A. Note that. It's very, very important. Complement of a set. So complement of sets is those elements not in A but in universal sets. Elements that are in universal sets but not in A. Don't forget these are universal sets U. So elements that are in universal sets but not in A, not in set A. Those are what we call complement of a set. And we can write it as this. Let's write that one too. So that will be X is equals to, so the element is going to be like A such that A is a member of U, universal set, and A is not a member of A, that is set A. So that's how you're going to write it. That is A such that A is a member of universal set and A is not a member of set A. That is to say, that's a complement set. It is in the universal set but not in set A. Simple. Consider the three sets below. The universal set is having 0, 4, 7, 9, 10, 11, 15. Then set A 4, 7, 9, 11, and set B 0, 4, 10. If you look at it very well, you can see set A and set B are inside our universal set. That's why I call it universal set, which contains all elements. So finding A union B, one is very simple. So a union, you join the two together. So just join set A and set B together. Simple as that. So A union B is going to be 0. That is, you pick from union B and you also pick from union A. So which is arranging ascending order, that will be 0, 4. You don't write the 4 twice, just once. Then 7, after 7, 9, after 9, 10, after 10, 11. So we have combined both the union of A and B, just like we married them together, like they got wedded. So when husband and wife come together, they become one. Same thing, A and B will come together to become one. That's what I call A union B. A intersection B. A intersection B is more like Don't forget our intersection. What's that element that is in A that is also in B? That's what we call intersection. Something that is common. Exactly. So when we say intersection, it's something that is common between A and B. So what is common between A and B? You're looking at A, looking at B. There's only one common element there, which is 4. So that's why our A intersection B is going to give us 4. So N A will be equals to, what's our set A? Just look at the elements. Number of elements in set A. What will be our answer? So number of elements in set A, just count them. We have 4, that's 1, 2, 3, 4. We have 4, 7, 9, 11. That's 4 elements. So just write 4 elements. So that's as simple as that. If you have something like this is also cardinality of B. That's how to pronounce it. Cardinality of B, which means the number of elements in B. So what are the number of elements in B? So you can either write it as N into bracket A or cardinality of B like this. So same thing. Cardinality of B means the number of elements in B. So what are the number of elements in set B? You can only see. Looking here, you only have 3 elements. 1, 2, 3. So we have 3 elements in B, which make it 3 elements. Let's find B into bracket B. What does this, how is this pronounced? That's power set of B. We talked about power set too under our type of set. So we talk about power set. Let me quickly revise that. Power set is a set of all subsets of a given set. The set of all subsets of a given set. So that means we are going to find the set of all the subsets of B. Let's quickly write that. So our B power set of B will be equals to what? So we are going to have empty set. Don't forget this is a sign for empty set. Comma 0. We are dealing with B now. So all the subset of B, we are going to write them out. 0, comma 4, comma, we're going to have 10 also. We have written them in 1, 1. I'm going to write them in 2, 2 again. That will be 0, comma 4, 0, comma 10, 4, comma 10. The last one is going to be 0, 4, and 10. So these are the power sets of B. We are only picking from B. So the possible combinations of B. Those are the possible combinations that you can join together. You can either have empty set, you can have 0, you can have 4, you can have 10, you can have 0, 4, you can have 0 and 10, you can have 4 and 10, you can have 0, 4 and 10. 3. Just like you're finding combination. Find A minus B. That's the difference of A and B. Okay. Difference of A and B. We talked about that one too. So difference of A and B. How do you get difference of A and B? I told you if you want to find difference of A and B, it simply means element in set A but not in set B. So what are the elements in set A that are not in set B? Let's quickly look at them. This A, this B. What are the elements in set A that are not in B? If you look at it very carefully, we're having 3 elements in A that are not in B. So what are they? We're having 7, we're having 9, and we're having 11. So just try them out. 7, 9, 11. Simple as that. That's A minus B. Difference of elements. So element in A that is not in B. What does complement means? Elements not in set B but in the universal set. That says what are those elements that are in the universal set but not in set B? Look at set B very well. What are those elements in universal set that are not in set B? So let's list them out. 0 is in universal is in set B. So 4 is in universal is in set B. You know that one. 7 is in universal not in set B. You write 7. 9 is in universal not in set B. That's 9. 10 is in universal, it also in set B. 11 is in universal but not in set B. You write that one too. The complement. 15 is the universal set, not in set B. Write that one to 15. So that make it B complement. So those are B complement 7, 9, 11, and 15. So what is a Venn diagram? A diagram used to represent all possible relations of different sets. It's just a diagram. That's why I call it Venn diagram. It's a diagram in a set that helps to represent all possible relations. That is the relationship between different sets. That is, how does set A relate to set B, and set B relates to set C. So it helps to show relationship between different sets. The Venn diagram can be represented by any closed figures, whether it can be a circle or a polygon, yes, but mostly they use circle for Venn diagrams. So it can be square, hexagon, that's six shapes that have six sides, etc. But usually we use circles to represent each set. You can use anything to represent Venn diagram, but mainly we used to use circle for Venn diagram. We mainly use circle for Venn diagram. This is a typical example of Venn diagram. This is how it looks like set X and set Y. If you check this Venn diagram, you can see this Venn diagram belongs to three sets now. We have set A, set B, and set C. So you can see this side showing A intersection B. That's A, what A and B has in common. So that's if you look at it very well, if you trace those circles, those two circles are only for A and B. C is not part of it. So that's why A intersection B. A intersection B intersection C. That means it's covering both A, B, and C, covering the three. Trace all the three circles very well. In that place, the three circle falls into that place. B intersection C, only B and C fall into that place. A is not there. A intersection C, only A and C fall into that place. B is not there. So for you to draw a Venn diagram, you must know the universal set and you must know the set. So this circle inside this diagram is what we call set A. And outside the diagram are what we call the universal set. So set A is inside the universal set. So under complement, this complement of A, that is to say, look for a complement of A, the element present in the universal set but not in A. And these are the universal set. You can see the universal set is drawn like you can see those lines in the universal set. So they are inside the universal set. Those are elements. Those lines are like elements. They are in the universal set but not in A. So this diagram, this Venn diagram is all called A complement. The elements are in the universal set but not in A. This A complement universal set. So this diagram shows the intersection of two sets. Intersection of two sets. That is set A and B. How they intersect. Don't forget intersection. What is common between them? So you draw it in the middle. You can see those elements in between the middle of them, joining them together. So this is not union, no, this is intersection. This intersection. Don't confuse intersection with union. Is intersection. So intersection will be in the middle. So this is another figure which is union. So this is a union. A union B. So A union B in Venn diagram is like this. This is how you're going to write A union B. You can see those lines. So you're going to draw everything because they must be joined together. They are married. So you must join them together since they are married. A union B. That's why we are drawing those lines on both A and B. That's A union B. So this one is called A union B complement. A union B complement. What does A union B complement mean? That is element that are inside A and B but not in universal sets. You can see this A union B. You already join them together with the white part but not in the universal set. That's what we do universal. So when you're asked to draw a Venn diagram of A union B complement, A union B complement, you're going to join them together. And this diagram is for A intersection B complement. So this one is A intersection B complement. You can see it's only the intersection that is white. All of that you are going to draw it on it because it's A intersection B complement. Just like from A intersection B. So this sign will be left behind. A intersection B complements. Since they are not in the universal set, you're going to draw everything out. So this Venn diagram for A minus B that we talked about the other time. Venn diagram of A minus B, that is elements are in set A but not in set B. You can see how it's being arranged. The line drawn are what we call the element in set A but not in set B. You can see it typically represents that. You can see the element in A are drawn A minus B, that is difference of A. That is those elements in A. You can see these are elements in A but not in B, so it's not represented in B. So those are just all about Venn diagram that shows the relationship between these sets that we're talking about. Let's move to types of relation. That is the different type of relation that we have in a set. So I'll be talking about just three: reflexive relation, symmetric relation, and transitive relation. So let's start with reflexive relation. In reflexive relation, every element maps to itself. That is, it refers back to itself. So in a reflexive relation, all elements ensure that they refer back to itself. What are we saying? A relation R on set A is said to be reflexive if every element of A is related to itself. So a relation R, we are talking about R, we are using this R as a relation now. So the relation R on this set A is said to be reflexive. So this R is said to be reflexive if every element in set A is related to itself. That is, if every element in set A is related to set A. Simple as that. R is reflexive if and only if A, comma A is a member of R for all A, a member of set A. What is this talking about? Saying R is reflexive if and only if A, comma A, we are just using that small letter A as it represents a number now. Like that A is representing a number in the set. So if A, comma A, that's two numbers, is a member of R, that is relation R. This sign means for all A. That is when all A is a member of set A. That is to say, A is related to A. That is, the first number is related to the second number. Let me quickly give an example so you can understand better. Let's say set A is equals to 1, 2. R now, which is the relation. So R must have 1, 1, 2, 2, 1, 2, 2, 1. They are reflecting back to set A. Let's check it very well. Look at 1, 1 is in set A. 2, 2 is in set A. 1, 2 is in set A. 2, 1 is in set A. That is to say, every element in this relation is relating back to set A. That is why this thing is correct. If you look at this, R is reflexive if and only if A, comma A, this A, comma A now, 1 and 2, A, comma A is a member of R, which is true. A, comma A is a member of R, yes. For all A, for all this A, 1 and 2, is a member of set A. So all this A is a member of set A. Symmetric relation. In a symmetric relation, if A equals to B is true, that is, if this is true, then B equals to A is also true. If A equals to B is true, then B equals to A is also true. In other words, a relation R is symmetric if B, comma A is a member of R is true when A, comma B is a member of R. A relation R is said to be symmetric only if this B, comma A, don't forget B, comma A means like we are using figures now. If B, comma A is a member of R, relation R is true. So if B, comma A is a member of R is true, when A, comma B is a member of R is also true. So that's when we say this relation is symmetric. Let me quickly give an example so we can understand better. Let's say set A is equals to 1, 2. So how do we know this set A is symmetric? Let's look at this relation. So we can say this relation is symmetric. Why? Because 1 comma 2 is a member of relation and 2 comma 1 is a member of relation. So if 1 comma 2 is true, definitely 2 comma 1 is also true, which makes it a symmetric relation. That is, the relation is symmetric. The last relation we'll be talking about is transitive relation. If x comma y is a member of R, that is relation, y comma z is also a member of R, that relation, then x comma z is a member of relation, which is true. In as much as s comma y is a member of relation, y comma z is a member of relation, then definitely we can say x comma z is a member of relation. As simple as that. That is, it is transferable. That's why I call it transitive relation. Relation of x comma y is y comma z. We can also transfer it to be x comma z. So it is transferable to z. So since x and y can relate, y and z can relate, definitely x and z can also relate. Let me quickly give you some logic why it is transferable. Look at this thing now. Mother and father is a member of a family. Father and a child. Let's say they just have one child. They're also a member of a family. Transitively, then mother and then child, he also belongs to that family, which is true. If mother and father is a member of family, father and son is a member of family, so definitely mother and son too, they are part of the family, transferable. So now let's look at set identities and law. So just follow me as I'm going. Number one, we have identity law. Identity laws, what does it say? Laws are just the rules and regulations that are guiding the set. That is the constant thing that are meant to happen when you are performing a set. So identity laws now says A union empty set, you always give us A. So if you join together A and empty set, it always give us back set A. Also A intersection universal set, it always give us A. So join when you find the common between A and universal set, it always give us A. That's identity law. Number two law, domination law. Domination laws. What does it says? It says A union universal set, it always give us universal set. And also A intersection empty set, it always give us empty set. That's domination law. Let's look at number three, idempotent law. Idempotent law says A union A, it always equals to A, and also A intersection A, it always give us A, set A. That's idempotent law. Let's move on. Complement laws. What does complement law says? It says A union A complement, it always give us universal set, and A intersection A complement, it always give us empty set. That's that about complement laws. Number five, you have double complement law. Double complement laws. What does it says? So this one says A complement close bracket all into complement, we always give us back A. As simple as that. So commutative law says A union B equals to B union A, or we can say A intersection B equals to B intersection A. Same thing. So when you do this, it will give us same answer. Number seven is associative law. Associative law says A union into bracket B union C close bracket equals to open bracket A union B close bracket, union C. So it will give us that. And also, if you try this, A intersection open bracket B intersection C close bracket, it will always give us equals to A intersection B close bracket intersection C. So it always give us that distributive laws, which says that A union into bracket B intersection C close bracket will always give us open bracket A union B close bracket intersection open bracket A union C close bracket for distributive law. And the second one we say A intersection B union C close bracket equals to open bracket A intersection B close bracket union A intersection C. You have to be very familiar with these laws. It's very, very important. Next one is De Morgan's law. De Morgan's law states that A union B all into bracket complement will always give us A complement intersection B complement, comma, then open bracket again, another one A intersection B all into bracket complement equals to, it will give us A complement union B complement. So that will be our answer that is going to give us. So absorption law state that A union into bracket A intersection B close bracket equals to A to give us A. Or we can also say A intersection open bracket A union B close the bracket will also give us A. So these two will always give us A. Next one, complement of universal set and empty set. So what does it say? So universal set complement, you always give us empty set, and then empty set complement, you always give us universal set. So they are interrelated. Set difference law. So what does it say? It says that A difference B will always equals to A intersection B complement. That's set difference law. So this sign means this sign, it means difference. Or you can also write it like this, A difference B. So they are both the same thing, whether this or this one, they are both the same thing. So if you calculate this, it always give us this. So let me quickly prove some of this law by doing this example. Let me just prove like two of the laws. Let me prove like two of the laws. So let's see how correct it is. So I will prove complement law first. Complement law says A union A complement will always give us universal set. So let's take for instance our universal set is equals to 1, 2, 3, and our A equals to 1, 2. So let's just see if this is correct. So our A union A complement. Let's find our A. These are our A 1 and 2. So if we join it together with A complement, so let's find A complement now. A complement. What does A complement means? Those elements that are in universal set but not in A. That's A complement. So what's that universal set that's in universal? What's that element that's in universal set that is not in A? That's 3 alone. So now let's join it together. So we already have A and we have A complement. So if they marry each other, so our answer is going to give us 1, 2, 3. So this 1, 2, 3 is equal to the universal set. Yes or no? Yes. So A union A complement will give us the universal set.